So just a little bit about myself. My name's Alex Palowich. I've been doing competitive robotics ever since I was in, high school. So it's been almost a decade now of experience in robotics. I have an electrical engineering degree. That's what I went on to do after my high school career. But I've always been involved in robotics and always had a very huge passion for it. I think VEXiQ is one of my favorite forms of robotics. I think it's so easy to understand and yet so complex at the same time. I really think they knocked it out of the park in terms of ease of use, and yet you can still really teach all these high-level advanced programming and engineering concepts with the VEXiQ. So there's a lot to be dealt with it, and there's a lot of engineering principles that it covers. But at its base, it's just a really easy to use, really beginner-friendly, tool-less platform for learning robotics. And if at any time you have any questions, if there's anything you'd like to ask, feel free to just type something into the chat box or turn on your mic and ask a question to me. I'm more than happy to answer any questions as we go along. So if something seems confusing, just reach out and let me know. And now the very first thing I want to cover is just where do we even find this new software? So VEXcode is the newest software from VEX. It's directly from VEX. They work with RoboMatter, but they're essentially the same company. So it's a group effort working together under the same house. And they've really revamped and updated the coding software that they offered you. They match the same exact style for the V5. So if you are working back and forth between the two VEX styles, it's going to be really familiar and it's going to be really handy for you. So if we go to the VEX Robotics website, I'm sure we're all familiar with it. So we click on the VEXiQ right on the top left-hand side, and this is where we find all of our major offerings. So if we go under products, that's where you find VEXcode. But the very first important thing you're going to want to get as well is this VEX OS right down at the bottom. And this updates your VEX firmware. It just makes sure that every device that's plugged into the VEX robot is working together and they're all on the same exact version of the firmware. So when they communicate, they all have the most updated hardware and the most updated settings. And this is really important too. If you're ever having issues with your programming or getting controllers to communicate with the robot, one of the first steps I always recommend is just updating the firmware on VEX OS. Now when we actually open up the program, it's just going to look like this. It's a very simple program. So right when you power it on, it doesn't really give you too much information. But when we go ahead and plug in our USB, when we plug in a VEXiQ brain to the USB, power it on, after we get the connection failure. Pardon me real quick, I'm just going to reset the connection. But VEX OS is going to show you all of your devices. It's going to show you if they're up to date or if they need to be updated. So this is definitely the first step. If you haven't done this before, it's a really, really important step. So right on the VEX Robotics page, VEX OS, scroll down. You can either download it for Windows or Mac, and then you're all set. And once you know that your products are up to date, you can also then move on to the VEXcode and Software tab. VEXcode is free to use, and this beginning page just kind of explains the two different versions and why they did this. So VEXcode was really their idea to be consistent across the blocks text in terms of syntax. So they want both the advanced and the beginners to be using the same commands, whether they know everything that they're doing is the same, is regardless, just so that when they come to the full text side and when they come to the V5, they've seen the same commands, they know how it works, and they're very familiar with it. So on the top, if we just go over to the download tab, that brings us to the page we want. Pardon me? Was there a question?
Hold on.
Did you have a question? Okay, no problem. If there are any questions, just feel free to ask, but it's not mandatory to ask any questions. So here are the two different versions for VEXiQ. They have not released the text version yet. They're going to release it later in the fall. But the IQ Blocks is fully released. It's version 1.0.01 to be exact, but it is a full release. So it's available on the Chrome store. It's available on the App Store for Apple iPad users, but you can also get a Mac and Windows version as well. And if you're not sure whether your computer is going to be able to run it, you can just click on the minimum system requirements, and that'll show you for each device what they recommend at least to get a good performance and get a good use out of the VEX code. So we've made sure we can download VEXcode. It's going to work on our computer. We're all set there. So you just click on whatever download you want. I click download for Windows. And then once you're done with that, it runs just a standalone program. So you're just going to go through your start menu, find VEXcode IQ blocks. And then when you start a brand new project, you're going to see almost this exact identical screen. So this is exactly what it looks like. Brand new project, nice and clean, nice, clear interface. And if you ever use Scratch, it's going to look extremely familiar. So they definitely modeled things after Scratch 3.0. It's the most common coding and programming education tool that is being used. It's free to use, so a lot of students, a lot of educators are already familiar with it. But if you haven't used Scratch before, don't feel scared or intimidated, because they really do a great job of explaining why they chose that and how everything works. So we'll start up in the top left-hand side with your file menu. It's very straightforward. File, you open, you save programs. You can open your recent programs and choose through what you've had open recently. So it does save, running the most recent programs, and the last up to 5 or 6 programs that you've done will be easily accessible. You can also navigate through your programs, but there's also a really great examples section. So if you're just getting started with programming and you want to see what these programs even look like, so they actually separate everything into categories. This is just an overview of all the categories. And I did want to kind of explain what these are, because they're a really great useful resource. If you don't know what the finished code or the finished product should look like, this is a really great place to start. So the first tab is templates. And templates are great because they take care of all of our robot configuration. So if you didn't want to go through all the mess of setting up your robot and you're just kind of taking one of the robots from the instructions that VEX gives you, they have some of the most common configurations right here that you can just choose from. I'm going to explain how that works, but I just wanted to show you what that would look like. So say I built the Clawbot, I built it from the instructions, and I was going to program it. Well, they actually saved me this step. If I go under the Clawbot template, there's a drivetrain version, and there's one with just all motors mapped out as motors. So we click the Clawbot configuration. We don't see anything in the code tab or anything out here, but if we go into the device tab in the top right, you see all of your motors, all of your devices are already added. And I know I'm getting a little ahead of myself, so I will go back just to finish talking about what the examples are, but that's a really great time-saving reason to use the examples. There's also different categories if you're trying to get motion, if you're trying to program just simple motion, if you're trying to program a drivetrain or something that's going to happen with the brain. And then there's also different tabs that explain the more advanced ideas like events, logic control, using the sensors and picking up those values and how you make those interact with your robot. And then things like operators and variables as you get into definitely more advanced ideas of programming. But VEXiQ Blocks does it all. It's a really easy to understand, really simple package, but the complication and the advanced level of programming is definitely there, and there's a lot you can teach with it, even at a higher level. They've also done a really great job of making video tutorials. So we're going to go through all this today, but if there's anything that you're coming back to and you're like, I don't really remember how we went through that or how we got set up with the controller, how we set up the drivetrain, there's a tutorial for just about every single basic action in VEXiQ Blocks, and every single step is pretty much planned out for you. And if you do click, so say I click one of these tutorials, there's actually an embedded video, and you can even make it full size, and it plays right in the VEXcode browser. And it has full sound and everything. You can drag it out of the way so it plays while you're coding, and it's really handy when you're just getting the hang of things to watch it alongside while you're actually coding. Excuse me, sorry. So I'm a huge fan of the tutorials. They do a really great job of getting everything set up, and they also do explain how the VEXOS works. So if a little bit of that beginning part of the webinar with downloading VEXOS and getting your robot up to date was confusing, this is a really great way to get a refresher course on that. So what do the other tabs on VEXcode do? Let's talk about it. So the slot tab is how you decide which one of the 4 slots the program is going to download to. So the VEXiQ brains have up to 4 slots, and you can choose any 4 of them, and then it will just keep saving that project to the specific slot. If we click the center tab, we can also name and save our project as something more descriptive. But for what we're doing right now, we'll just leave it as VEXcode project. But if you wanted to get in the hang of naming it something right off the bat, that way you just get a little more organized and you don't have too many programs that are just named VEXcode project, because it does get confusing the more you just keep that default name. And then as we go to the top right side, we see this brain icon. Now I unplugged the VEXiQ robot specifically just so I could show you this. But when nothing's plugged in and we click on the brain icon, it should show no brain connected, no information, and all these tabs up here should be grayed out. So we cannot download, run, or stop a program until we hook up a VEXiQ brain. And I'm going to plug one in now just so you can see what it does. Okay, so now our IQ brain is hooked up. We have our green brain, and when we click it, we see the full information. The VEXOS firmware is up to date. If it wasn't, we would just want to go back into that VEXOS utility and update it there. But now we see we can download, run, and stop programs. And let's go ahead and test that out and make sure our brain is working like we want it to. So one of the first steps, and we'll treat this like a brand new program. So let me go back into a fully open template, because I am in the Clawbot, and so we'll just get rid of that. So this is a fully brand new, you're just starting up VEXcode IQ blocks for the first time. You have nothing saved and you've never seen it before. So this is the page you're going to see. So now that our brain is hooked up, we want to go ahead and test a program and make sure that we can work with it. So we click the Looks tab on the left-hand side, and this gives us all of the blocks that correspond with the brain. So we can have it, print words, we can have it play music, or not play music, we can have it play specific notes, and I guess you could play a whole song, so you could play music. But there's also just a bunch of different sounds and different interactions you can get just with the brain itself. So this is with no devices configuring, it only knows that we have a VEXiQ brain, and that's what we're programming. So the very first step is we're going to just click and drag out this print hello statement. And if you've ever used block style programming, you'll see this kind of natural snap feature. So when you drag the block close to it, it's going to show you this kind of dark highlight, and then you just release it, and it should snap right into the upper block. Now when you click the upper block, it should allow you to move all the blocks attached to it. And this is just the basis of block or scratch programming, and this is why it's so popular with students, with educators, because it really lets you know what's connected to what and how your code works in terms of logic. So it starts at this first when started, and it's just going to go down the line with every block that's attached to it. So now we have our very first print hello program. Let's go ahead and download that and see what happens. When you click download, it does ask you to save the program. You don't have to do that, so I'm just going to hit cancel. It's still going to download to that slot, and then I'm going to hit run. And it is a little confusing, or it's hard to see with the webcam what's going on in the brain, so I do just have a picture here to show you what should happen. So you should just see, real simple, just hello right printed to the screen. The name of our project is at the top, VEXcode project. And now we know that our program was successful. So it downloaded, we hit run. When we ran the program on the brain, this is what came up. Awesome, so now we have printed to the brain, we were successful there. We know that our program's download, the robot is communicating to VEXcode blocks, and we're ready to get started. And the very first step, I think, with any program, with any setup, is going to be device configuration. So I showed you before how the templates kind of help you set that up already. You can choose from some pre-made robots or some common robot designs. But say we had a fully custom robot, or we just want to know how to do it from scratch for our own sake. So this device tab up in the top right, I'm not sure what it looks like, I guess a motor. So it's the devices tab. So we click on that, and then we can add any device. So the very most basic device, very first thing you're probably going to want to add is a motor. Now we do kind of want to use the drivetrain for what we're doing here, or for most basic robots, but let's talk about just a basic motor, and then we'll get into why we want to use the drivetrain. So let's start off adding just the left side motor to our robot here. And I just wanted to show everyone real quick with my webcam. So the robot I am using right now is just a simple autopilot robot. It's got a drivetrain chassis, and then all of the sensors are configured to it as well. And there are instructions for this in every super kit. it's at the end after you make the claw bot, or you can make the autopilot bot as well. So we have 2 motors for our drivetrain. So I'm just going to set up the left motor right now. And the left motor is in port 1. And I really like to get in the habit of naming and organizing the names of my motors and the directions that they are corresponding with. So I'm just going to name this one left motor so that when we go back to call it, or when I go to use a motor command, I know that I'm referring to the left motor and I don't have to remember what port I was doing. You can also change the names of the directions. So say this was an arm or a claw and it wasn't necessarily going forward and reverse, I could change what I call those directions. So it can be up or down, left or right, and it's really up to you, or depending on what the motor itself is actually doing. In the reverse tab on the bottom, just sets whether these directions need to be reversed. So for example, if I'm using 2 symmetrical design motors, but one of them is the right-hand side of the drivetrain, one of them is the left-hand side, one of them would need to be reversed, and I'll show that in just a second. So we have our left motor here. We're all set up. Forward and reverse works fine for me. We're going to add that as a device. So now that we have a left motor added in our devices, you see we now have these motion commands. And these weren't available. They're only available once you add a motor, but then it adds all these commands. So we can just tell the motor to spin. We can tell it to spin for a certain position. We can tell it to spin to a position. We can just stop it. And there's other settings as well. So you can change the maximum velocity. You can change the motor's braking habit, whether it stops at a perfect point and holds that, or whether it kind of lets the motors coast and come to a stop. And then you can also set things like the max torque and then the timeout as well. And this is getting a little advanced, but the timeout command, if it's confusing, you can always click the help icon. So right in the top hand side, this question mark. And now when I click on the timeout block, it explains to me what the set motor timeout command does. And this is a really great tool and a really great resource for every single block. So even just a spin command. It brings up the help tab and it shows me how to use it, how to set the different parameters, and what it's telling the robot to do. So if you're ever confused on what to do with a block or where to use a block, the help tab is going to be your best friend. But motor timeout essentially just makes it so if the motor continues to try to, or if it keeps moving and it's hitting something like a wall or an obstacle and it can't turn, after 1 or 2 seconds or however long the timeout is, it will just shut off the motor because it can't keep moving. So it's a really good way to keep your motors from getting worn out. So if you were driving for 100 inches into a wall and you hit the wall after 10 inches, you wouldn't keep driving. The motors would know to stop and to not burn themselves out. So it's a really useful tool, but if you ever wanted to understand how it works, the help tab is going to be really handy for that. But let's just try a basic motor command. So we just want to have it spin forward for 90 degrees. And with editing scratch programs or editing block style programs, everything is attached to the blocks above it. So when we click this hello or this when started, it's going to grab all of our blocks. When we grab the print hello blocks, it's going to grab that and everything below it. So if we wanted to pull out this print hello statement, we would actually have to take off the spin command, then remove the print, and now we can put the spin command back in. And that's just a little nuance of programming with Scratch or block style programming, and it's something you're going to get used to. But it's fairly simple, and the more you mess with it, the more you get the hang of it. So now we have our spin left motor forward. We can actually change this to turns. And since 90 degrees isn't a lot, we're going to make it 1 turn. So now that we have our simple motor command, we're ready to download and run it. So we're going to download to that same slot. We could name it and we could save our program at this point, but I'm still not going to worry about that. I'm just going to cancel it, still download the program. Let me turn on my webcam so everyone can see. Just want to make sure, can you see the webcam? Is it showing up for everybody? Okay, thank you, Dean. So sorry, I just wanted to make sure everyone could see it. Like I said, if there are any questions, if there's anything that you wanted to bring up, feel free to just type it in the chat, or just you can turn on your mic and feel free to derail. I have no problem answering any questions if something's coming up that you want to know then and there. right, thank you, Frank. I appreciate that. All right, so you guys can see the robot. I'm going to run the program now, and it's only going to spin the left motor for one full turn. So we're going to see what that does. Exciting. So that was just a very simple program, very simple. We only turned the left-hand motor, but now we want to get them both to move. We want the robot to move forward. So similar to how we just added a left motor, we could always go in and add the right motor as well. So we go in, our right motor's on port 6, we name it, and then we could spin the right motor at the same time, have them both spin together and achieve that forward motion. But a really easier way to do this is with the drivetrain. So I'm actually going to just delete my left motor so we can use that port now for the drivetrain. And now when we go to add a device, instead of picking the motor, we're going to pick the drivetrain device. So it asked what's on the left motor, select a port, and it was 1. Our right motor was actually on port 6. And this is just the standard autopilot. I do have a gyro, but I'm not going to worry about that right now. It's just a little confusing. So we'll leave the gyro out of it, and it actually is just going to ask you for your drivetrain settings. So the most common, most typical drivetrain out of the VEX directions, it actually does use the 200 millimeter wheels, but you could change that if you were using bigger or smaller wheels, and you can also change the width of your specific drivetrain. You can also change the drive behavior so that this is now seen as forward. So whatever the highlighted blue arrow is what orientation your drivetrain is in. And if you were using a smaller or larger gear ratio, you can also account for that here. And what these drivetrain settings do is they let the robot know exactly how much output to get, so either a 12-inch distance, to get the robot drivetrain itself to move 12 inches, it needs to know how big the wheels are, how big the spacing is, and how big, what the gear ratio is. So it knows exactly how much to turn those motors to get the desired output. And the same goes for turning as well. So once you add in all these settings, it does make your turns a little more accurate even without the gyroscope. So now we have our drivetrain. And the nice thing about the drivetrain, if you notice, we didn't even have to reverse the right motor. So it already took care of that because it knows it's on the right side as opposed to the left side. So that's another nice thing about using the drivetrain, another way that it makes it just a little easier. So you'll see now it actually got rid of our motion commands. This code is still left over, but if we went to compile it and run the program, it would show up as an error saying that we never defined that left motor. But I'm just going to drag it over to the left-hand side, and that's actually how you just get rid of any code you don't want. You just drag it over to where the code blocks are, and it just deletes it. But now we have a whole list of drivetrain commands. So these correspond to the drivetrain specifically, and like I said, after we set our settings, the wheel radius, the drivetrain width, we now have a lot more accurate drivetrain output. So if I have it drive forward for 10 inches and then turn right for 90 degrees, it should get a really accurate output because it knows exactly what it's working with. Now, obviously, there's some friction, there's some issues in real-world practice, but this is still the closest we're going to get through no sensors and just settings of the motor and the drivetrain. And you'll see some familiar behaviors for the drivetrain as well. So you can set the overall drive velocity, the overall turn velocity, the way the motors stop, and similar with the drive timeout as well. But so we have our simple drive forward for 10 inches, turn right for 90 degrees. Let's go ahead and see how this pans out. We're going to click download in the top right. And now we are all set to click run. You can click run through the VEXcode software, or you can also just navigate through the IQ Brain and select run on the brain itself. But here's what we get. So like I said, not an overall perfect turn, and I also did still have the tether in, so that might have kept it from making a full 90 degrees, but still really accurate and really close to 90 degrees, especially, like I said, for not even including the gyro. There is a gyro on the robot, but this was just straight programming with only the drivetrain configured. So that was kind of the next step, the next thing we needed to unlock in terms of just basic drivetrain and robot navigation. So you could use this to, navigate mazes. You could use simple drivetrain commands to do a lot of different things. But let's say we want to add a controller and we want to drive it around with the drivetrain, or we want to, we have a robot, but we want to control it ourselves. How do you set that up through VEXcode? We use the controller as a device. So for just for the sake of this demonstration, I'm going to add one more motor, and we'll say it's on port 8, and this is our arm motor. Now there are no motors on my autopilot bot, but this is just an example to show you how you can map the controller. So as I was saying before, I really like to use custom names for directions. So say this was an arm motor, we could call this positive direction raise, and we could call this negative other direction lower. And I just wanted to show this real quick because now you see, before when we were using the left motor and right motor, it was giving us directions of forward or reverse. And now when I drag in this arm motor command, I spin the arm motor, I either raise or lower it. So it corresponds to the directions that I chose, and it makes it a little bit easier when I'm going back to program and I'm saying, okay, I want to lift up my arm. It gets a little confusing when you only have forward and reverse, and you're not quite sure was raising the arm forward or is raising the arm going reverse? So this just makes things a little more clear and a little more organized when you're going back to code, and it also just makes it a little easier for anybody that's looking at your code to understand what you were trying to do. So now that we have an arm motor and a drivetrain, this is similar to a basic robot. So if you were programming, Flex from the recent years or one of those simple VEX designs, some of them are really just a drivetrain and a lift motor. So say that's what we were working with. How do we program that to use it with a controller? So we add the controller as a device, and it's actually going to map the drivetrain to these joysticks automatically. So we click the one joystick, and now it's left hand or left stick drive. So the left stick drives forwards, backwards, and turns it left and right. When we click the joystick again, it switches it over to the right hand stick. So same thing, just one joystick controls it all, but now it's the right stick. And you can click through the joysticks and cycle through this arcade style where the left stick drives forward and backward and the right stick turns. You click it again, it's tank drive. And if you click it again, it shuts off. So this is how you can cycle through the different drive behaviors you want. I personally like tank drive, so just left motor, left hand side, right hand motor, right hand side. But we have an arm motor. So how do we map that to different buttons? And you can actually click any button combination. So we could map it to these front E buttons. We could also map it to the left button or the right button. And it shows you the motor that's mapped to it. It shows you which button corresponds to which direction. And if you weren't happy with that, so say we want, the lower right-hand button to raise our arm, we can actually click this blue swap arrow, and it just changes the two directions and vice versa. So now raise is the other button and lower is the top button. And now that we've added a controller as a device, there's actually a lot more things we can do with it. And I'll get into that a little later with events and such, but now we can have our controller buttons trigger certain events and trigger certain activities. So you see that as you add more devices in your configuration, it kind of expands on what you're allowed to program and what your options are. But it's also really handy because if I took this controller out and say we didn't even have a controller, it wouldn't give me the option to use the controller. So you're also not cluttered up with a bunch of commands and code programs that don't apply to your robot. So in a way, it is pretty nice, and it does kind of keep things clear with what you're working with. And while we're talking about the different code blocks on the left-hand side, I did also just want to bring some attention to these other look commands. So the brain itself has a lot of options. You can teach some decent programming with it, and you can also get a lot of feedback from it. So we could say after we were done driving forward, turning right, and raising up our arm motor, we want to print, lift, or arm was lifted. And so this is a really great way to get feedback to the user. And you can have this print to the screen. One thing I like to do is also maybe just play like a siren. And this is a really easy feedback, so you don't have to look at the robot, you don't have to be watching it. You can just hear that noise and know, okay, that part of the code was successful, it made it to that point. And you can also have up to like 12 different sounds, so you can correspond them to different things and different points in your program. So there's a lot of cool little helpful reminders and helpful little tricks and tips you can do with Scratch coding, and they make your programs that much more interactive, and they give you that feedback that you're looking for. So rather than questioning whether it got to a certain point in the program or whether something happening, you can hear that feedback, you can see it printed to the screen, and you know that you made it there. And then just below the sound tab are all of your events. So every VEXcode blocks program always has a when started when you open up a new project, but it doesn't have to be that way. So I could drag this whole thing over to the left-hand side, and I can have my whole program started when I push a button on the brain, or if I had a controller. So I go back and add that controller in again. I can have a whole program or a whole block of chain or whole chain of code commands started with the controller buttons pressed, when the controller button is released. And so there's other ways to get your program initiated. You can have the program started, but then wait for your input to execute a certain amount of commands. And this just shows you some more options with the controller programming and how you can kind of get more interaction out of your robot. And you could even have a when started block, a drive forward command, or some other steps over here, and then an optional command that you only want to happen when the controller button is pressed. So this shows you how Scratch handles multiple scripts running at the same time, and how you can actually get a lot more complex with your programs, I should say, because of all these different simultaneous actions. They call them events, and it's anytime an event is triggered, it just starts a new line of code. And there are some pretty great examples of it. I didn't want to take up too much time talking about this, but they explain some example programs and why they use them. So for every example program, and I just wanted to pull one out real quick, this one kind of shows how the when events are started over here. So the when controller button is doing, is pressed, or when the other button is pressed, it starts a different action. And they also explain it too. So in all these example programs, VEX is really good about adding in a note, and then usually in a couple sentences or up to a paragraph, they explain exactly what the program is doing and why they designed it to do that. And this is a really great feature about the example programs, and another reason why I really like them. And the last thing I was going to talk about, or I don't want to take too much time, I know it's getting closer towards the end of this, was the sensors and how to use the sensors and how VEXcode handles the sensors. So as with everything else, there's some really great sample programs. So if you did want to dive a little bit deeper into it and understand more about sensors, I would absolutely recommend going into the example programs. And just under sensing, they have an example for each sensor. So whether you were looking to get used to the bumper switch, getting used to the vision sensor, the color sensor, the gyro, there's an example for every sensor. So they really do a great job of showing you how exactly you would use it and what that would look like. And if you were looking at the examples and kind of wondering how they have these little notes and stuff, or how they add in these comments and how they organize their code, what they do is they just right click and you add note. So you can add a note, you can click and drag it anywhere in your program, and you can just write a little comment, this part changes the speed. So you can have little side comments or little, hanging notation next to your code to kind of explain it. But one thing they also do is they have comments in each code. So down at the bottom on the left-hand side is the comment tab. And these are just lines that are ignored by the compiler or the VEXcode. So you can type in whatever you want here and it's never going to affect your program. And as you can see, these comment lines, they just give you a little more idea of what's going on in each state. So it's a really good idea to get your students or anyone that's programming to put in comment lines before each step. That way they're organized, they know what's going on with their program, and so does whoever's looking at it. And I did just want to touch on a couple more quality of use things with VEXcode. So say this is our program right here, and we kind of want to blow everything up. In the bottom right-hand side is these plus and minus magnifying glasses. So it's just a zoom function. We click on the plus one, and now we can see our code nice and blown up a little bit bigger. Same thing with the minus. We can zoom out and see everything we're working with. And they've also done a decent bit in terms of making it feel like a real code-based or coding editor. So if I click and drag these group of blocks right here, if I click on this repeat until I'm dragging around, I let go, I can actually hit, I can right click and duplicate it. And so now I have two versions of this, and this is just an easy way to add more code. So say I wanted to do it twice, I can now add that step in twice. Or even better, so say I'm dragging around this code of blocks, I hold Control C for copy. If I hit Control V for paste, I can paste it as many times as I want, and you can also use Control Z to do undo. So as you get faster and a little more used to the coding, these are quick little shortcuts that are going to make your life a little easier. Because as you find yourself repeating functions or repeating certain lines of code, you can just duplicate them, and it saves you some time. There's also things like if I right-click on this white space on the right-hand side, I can always collapse all of these blocks. And so any of those nested statements, it just condenses them into one quick statement. So if you knew what your program did and you were just kind of sick of looking at all of it, you can always collapse the blocks. Or if you accidentally find yourself smushing everything and you want it all back, you right-click and expand blocks, and this shows you exactly what's happening. Okay. Now we discussed device configuration before. So I am just going to pull out one of these autopilot templates that I'm working with. So this went through and it just repopulates all of our devices. So we added the drivetrain, and it basically went through, add a device as a motor, set the motor port. So it sets all the ports from the autopilot robot directly from the instruction booklet. And now that we have all of these different sensors, when we go into sensing, once again, it populates all of these code blocks. So there's now a ton more information we can pull from them. And the last thing I wanted to touch on is Scratch's shape-based coding. And when I mean shape-based is that you will notice, so for certain code blocks, they have these rounded edges. They're circular. Some of these code blocks have this hexagonal sharp edge to them. And what that corresponds to is where they're going to fit in certain statements. So say we have our if statement. We want to use, a conditional if something's happening, then execute the code in this block. So what can we use in this block? So you see it has that hexagonal, six-sided sharp edges. So we can only use these conditions that are in a hex form. So we couldn't say if the drive heading in degrees, because that's not a statement. It's not telling it anything. We can say if the brain button is pressed, then do this code. And that fits right in there. And you can see that highlight, and it just snaps right in. So that lets you know what is going to fit where, and it literally will not let you put invalid statements into those spots. So there's a ton to do with Scratch programming, and I really apologize that it's such a wide world. I know we're getting close to the end of the webinar, so I didn't want to take up too much time. But by all means, feel free to have a heyday with it, mess with all these stuff, check out the example programs, look through the tutorials. And if you ever have any questions about using a little more of these advanced topics, I'm doing things like the different conditional operators, using things like custom variables and how that works, please reach out to me. I love talking robotics, and I'm always happy to do it. And my information is just right here as well. So if you ever have any questions, if something about this webinar was maybe a little confusing or you just wanted to dig a little deeper, please feel free to reach out, give me a call, give me an email, and I'd be happy to discuss things. And we do have upcoming more webinars and some teacher training sessions where we're going to go in a little more detail about custom variables, using conditional sensing programs, and everything like that. And if I could just end with one quick point. So under the VEX IQ tab on the VEX Robotics page, they actually did a really huge overhaul of their education. So you go all the way over to the right to STEM Labs. And there's a whole bunch of educational content. So for your students, for after school programs, there's a full lesson plans on getting started with programming, using VEXcode with the autopilot bot. There's other also fun activities like, building a tower that's going to withstand an earthquake and stuff like that. But they have full teacher guides, full teacher lessons, unit plans. They talk about why we're doing this and what engineering principles are being learned. And it's all applicable with VEXcode IQ blocks. So they're really doing a great job of, giving a lot of extra resources. The software itself is great, and now here's some activities and ways to get used to it and ways to learn it. So I think the STEM labs are a really great tool, and they're kind of a helper with learning the VEXcode IQ software. All right, so at this point, if anyone else has any questions, feel free to fire away. But other than that, thank you so much for your time and enjoy the rest of your day. I really appreciate everything. Thank you, Frank. I really appreciate that. Have a great day.